Right, so this is lesson 1 in the representation of data unit, and representation of data is how a computer uses information and how it makes how information is represented in the computer. So the first thing we talk about when we talk about representation of data is the file sizes. Now there are different file sizes and they work upwards, and we'll just go through what the sizes are and what they mean. So the smallest file size that you can get in a computer is a bit, and a bit is one piece of information. The next size up is a byte, and a byte is 8 bits. Now that's the first bit that's quite confusing. Having said that, it gets easier, because after that we've got kilobytes. Now kilobytes are 1024 bits. Now this is where it gets really simple, because then after that we've got megabytes. Now these are the ones that you're starting to hear about. And megabytes, bytes, I've spelled bytes wrong. Megabytes are 1024 kilobytes. And after that we've got gigabytes, and that is 1024 megabytes. And after gigabytes we've got terabytes, and guess what they are? 1024 gigabytes. And it gets bigger. The next one after tera is a petabyte, unless I'm running out of page, and after that it's an exabyte. And they're always 1024 of what's gone before. So as long as you can remember what went before, it's 1024 of it. If you want to try and put some kind of thought process on it, if you wanted to put the entire world's data onto a computer, they reckon that the entire world's data would take no more than 4.5 exabytes. Now that source came from Wired, so whether you believe it or not, that's what they worked out, that's what they theorized as. Now, the next question is why 1024? And this is where we talk about binary. Okay? Now, all computers work in binary, which is ones and zeros. And when we talk about a bit is either a 1 or a 0. So as you can see, it's falling all together. Now, why do we have 1024? Well, because when we put things together, you have to count it in numbers. So but it doubles every time. So we have 1 bit, and then we double that, it goes to 2, then 4, then 8, then 16, then 32, then 64, then 128, then 256. After 256 you've got 512, and then after that you have the magic number 1024, and that's the reason why we always talk about it in 1024, because it doubles every time. Now, as you've noticed, when I've written these, I've written them backwards, because that's the way that we always represent numbers in binary. We always represent numbers counting backwards, so backwards across the screen, so right to left rather than left to right. It's a bit strange, but it works. Now, if I just work on this, I'm just going to start with 1, 2, 3, 4, 5, 6, 7, 8, which is, all these together, is 1 byte. So now that's 8 bits. Right, so what we're going to talk about is how the numbers are represented. So if I want to represent a number, I can represent any number up to 254. in here, or 252, not 254, 255. Okay? And the reason why I do this is either representing a 1 or a 0. So I can, if I do 1, 1, 1, 1, 1, 1, 1, 1, that will equal 255. Now, if I take one of these out, I can then take that 0 and a 0. So I know that is 255 minus 10. So that one number will equal 245. And this is all about representation of data. This is how information is represented in a computer. They're represented by bytes within a computer. Now, this will work for any number in the world. So again, if you pick a number like 72, this is how you work it out. When you work it out, you do 1, 2, 4, 8, 16, 32, 64, and 128. And if I'm trying to represent 72, what I'll do is I'll say, right, well, I've got 64 in 72, and then I need to add on to 64, I need to add another 8. So if I say that, then that'll make me 72. So that'll work. And then 0, 0, and then fill in the blanks with zeros. And say I've got 164, 18, and that will equal 72. That's the easiest way of representing information. Okay? Now numbers are easy because numbers are just the simplest way, where we just do 1, 2, 4, 8, 16, 32, 64, 128, and we can just work that out fairly easily by putting ones underneath the numbers that we know. What about words? Now words are slightly different because obviously words, well, these are just numbers, so how do we represent word? Well, the way we do it, there are two main ways. There is ASCII and there is Unicode. And what these are standards. And when we have a standard, a standard is basically a way of saying this will be the same for the world. And most computer keyboards work on an ASCII character set, which is basically how we see it on the top of the keyboard, QWERTY. And it works by assigning numbers to letters, or numbers and symbols to letters. So as long as I've got something in the computer to say, oh, that's a keyboard press, it must represent a letter, then I can work it. So I know that 65 is an A. I think it's a lowercase a actually, so I'm pretty sure of that. So when I so if I sent this and then told the computer that that's a number, that's a letter from a keyboard press, then it will work it out for me, and it does it. And that's what ASCII does. Unicode is slightly different. When we started to have keyboards for different languages and different types, such as Japanese. I'll pick Japanese because it's Japanese. Japanese has an entirely different character set to us. Obviously, they use something called kanji to represent their letters. Well, that's going to be really difficult because obviously their keyboard is going to be different to ours. So what they did was they developed these Unicode standards, and these Unicode standards are basically a standard for if you have a Japanese keyboard, or if you have a Cyrillic alphabet like Polish or Russian, or if you have a Greek keyboard. These ones and that's what the Unicode standard is for. But it's to understand these two key terms, ASCII and Unicode, the fact that there are two different standards for how the keyboards have to be laid out and how the computer can interpret those button presses as numbers. Now, what I want you to take from this lesson is the two standards that we've got, ASCII and Unicode, as ways of representing letters and symbols in a keyboard in the computer, and also the way that binary works. It's basically working from left to right, and it starts with 1, 2, 4, 8, and it doubles every time until you've got enough numbers to represent any number. And we've also looked at the different file sizes. The smallest file size is a bit, a byte is 8 bits, a kilobyte is 1024 bits, and the sizes go up by 1024 every time. And as long as you understand that, that'll be enough for the exam.